So I'd like to now welcome Michael Fink to the stage, who's talking about creating time to care with an artificial intelligence-powered platform.
So the shorter summary would have been finally a geek on stage, so I really appreciated you entertain the computer science for a moment here, because I thought that was a great setup today in the sequence of the talks that we heard. We heard a lot about that we need to encode the clinical knowledge in order to make it comparable, and we need data. And the need for data, I think, is exactly what I wanted to talk about here, which is how does the physician factor into this? How does this factor into the workflows that we have? Because I believe what we are in a transition in is we are trying to get things electronically, and as part of the transition, we're trying to bridge the need for data. You know, when we say the enterprise would love to have everything structured and clinically encoded. Unfortunately, the physicians, the caregivers, have to carry the burden for this in many cases, because they are the ones that we asked all of a sudden to express their findings and knowledge in addition to using the narrative to do it, also in some kind of encoding. And when you look at the things that we offer to them right now, they're basically two different worlds. On the one side, you have dictation, which is a method where they just pick up a microphone, they dictate, and some person listens to the recording, transcribes it. It's very convenient for the doctor. It's somewhat not good because it takes a while in order to get the results. But the worst thing is that we don't get any data out of it, because its clinical data are lost as part of this process because it's free-form narrative. On the other side, people are trying to get doctors to embrace the idea of them structuring the data accordingly by entering them in a structured form in a medical record system, which is a great method in terms of, from the computer geek perspective, this would be perfect if I only make the doctor say it in that way. But unfortunately, the expressiveness of what the doctor needed to express in the first place is lost, because once we ask them to only give us the structured data, we really lose the thinking that goes into the process for the doctor. So while being the failure in the family, because I'm the only one who didn't study medicine but went into computer science, I felt there was enough room in order to contribute to the case by looking at the problems that doctors have. And the problems that doctors have these days is, I mean, this is one out of many studies that show that today the doctor spends about, at most, 30% on real clinical interaction. That's how much time is left for them to spend with patients. And the bulk of that time, in fact, goes into the administrative portion, the documentation, the working through the EHR in order to get the right structured data in there. And that's not a good outcome. Which is the reason why, for us, I made it our mission statement that is, for me, the mission statement, and should be for all of us in HIM, that is not the future that we should allow. So what I have here is from a clinical journal, some doctor published the summary of a patient visit from the perspective of a girl that went to the doctor. The thing that the girl remembers is, I was with the doctor, I spoke to my parents, I didn't see the doctor because he was turned away from me, he was facing the screen in order to do his tasks in the electronic medical record system or some kind of documentation system. Which is not how it can be. I mean, providing care is about engaging with people, engaging with patients. So we need to all work together that this is not what we should be willing to pay as the cost for technology in healthcare. We need to turn this doctor around again and face towards the patient. And so here's the geeky side. So all the things that I wanted to talk about today is what people refer to as artificial intelligence. So I'm working on this for the past 20 years in the company. I don't view this as artificial intelligence, I view this as algorithms that are trying to help us to do the following. When the doctor speaks, to be able to not just recognize what words they're using, but we want to understand what is actually what they are trying to do here. And so when the doctor says this, we have technology that automatically structures the information. And then it takes the information to the next level that it's trying to encode it, which is why I love to talk about ICD-11, because that's core of what we do, is trying to understand what the words mean, what the clinical concepts are, so that through the computer we get assistance in this conversion from free-form narrative into structured and clinically encoded data. which means we would have the best of both worlds, because in some ways we now have the narrative and the data, and we didn't make the doctor specifically work towards the data, so they automatically flow from how they would be documenting in the first place. So if this is the basis, and then there's one other thing I want to talk about, which is it flows from the first one. So what we are concerned about is we want to create documentation for the doctor that isn't just the text. So what we set out to do, and that's the artificial intelligence part, is that we try to translate what the doctor says in free form into a fully structured and clinically encoded document. So what it means is there's a standard in healthcare in HL7 called the clinical documentation architecture. So these documents allow us to represent the free-form narrative and the clinical codes in SNOMED, ICD-10, and RX norm related to the clinical concepts. Which means if we can capture this from how the doctor speaks, we get out of every engagement with a patient a document that isn't just the words, but is also which medications were ordered, which problems were reported, and what kind of follow-up did I request as an order here. So this is the meaning for clinical documents. So the task that we set ourselves now is to say, what can I do if I am able to capture clinical information in free form in the manner that I described, so that we capture, we recognize the dictation, we turn it into structured and clinical information. Can we use this clinical information in a different manner so that I can actually help the doctor to do something positive at that moment? Can I help them to provide feedback in terms of what they're currently trying to accomplish, to help them to possibly provide better care or to provide more specific clinical documentation? So what I wanted to do is to walk you a little bit through how we took these capabilities stages from where we changed what was there to something that I believe can be done different today. And I wanted to do this by taking the individual steps here for this, which I hope we can advance. So we started many years ago by saying there shouldn't be a process like clinical dictation anymore. Instead of this, we wanted to have a process in place where when the doctor dictates, we can use artificial intelligence to automatically translate the dictation into the structured and clinically encoded document, and take this clinically encoded document and have it reviewed by the transcriptionist. So as opposed to the original process where they were listening to the whole recording, we created already a full document with all the meaning attached and had a review process. And this was all done with technology, and it scaled. And this is something that actually is significantly in use these days, which I hope we can get to. Or not. Can you advance the slide, everyone? Thank you. So just to give you a sense of the impact of this, today with artificial intelligence technology, we do every year transcribe automatically about 500 million minutes of dictation. So this is about 200 million different structured and clinically encoded documents that were created without asking the doctor to click on boxes or to figure something out in a drop-down menu. It was done fully automatic and then reviewed by a medical transcriptionist to ensure the accuracy. For her to work, this makes it is about 2 times faster to review a document than to type the document in the first place. So we have 2 wins here. We are much faster thanks to the technology, and we have more value because we create a clinically encoded document. So next stage is the one involving the doctor in this process. And so you took the same idea, recognizing, understanding, and gave the microphone directly to the doctor in order to allow them to dictate directly into the medical record system so that they can review their own documentation, and they're basically instantaneously done once the documentation is done. So this system, after starting many years ago, runs for about 250,000 doctors right now. 250,000 doctors every day decided that it's easier, instead of dictating and going through transcription, they dictate directly, get the results in the medical record system. They document about 150 million, this is last year, 150 million patient encounter. But the one thing that I'm most proud of in this is that we calculated to have saved about 2 million hours of physician time this way, of time that they would have spent otherwise having to review things, having to dictate more because they wouldn't have the right clinical context. So 2 million hours given back to take care of patients instead. The next level here for, so now we've talked about the fact that we now create all these clinically structured encoded documents. And to me, this is the opportunity for all of us to look at clinical documentation improvement in a different manner. So we, instead of looking at it in a manner that today people have looked at an encounter, go through all the documentation, figured out which patients to focus on, which chart to focus on, and did the review. We changed this review process with artificial intelligence in the manner that we said, okay, instead of having the CDI person to have to figure out which cases should I review, we have the technology read all the medical records systematically. So everything is read, everything is pre-read before the clinical documentation specialist even encounters it. Then we order the cases that are there based on priority. So which ones are most important for a CDI specialist to look at, and because of what of deficiencies that we believe are currently in the clinical documentation. So we changed the process from finding a needle in the haystack to actually reviewing the whole haystack and ordering it based on priority to allow them to have a more efficient process. And the more efficient process is essentially that the computer prepares everything for the CDS specialist already by laying out, here, these are the gaps in documentation, and this is a potential query that I should be sending to the doctor. All done automatically with confirmation from the CDS person. I think where it gets really exciting now is when you take this approach that is a classical CDI approach. So the doctor documents, somebody reviews the documentation, figures out there's a gap, next step is I should send a query to the doctor in order to fix it, which I think is sort of a retrospective approach to clinical documentation improvement. I wanted to show you something where we took this retrospective approach to make it proactive, because as the doctor documents, we already know what the gaps would be, because the technology can not just discover the words, but also the concepts. So how can we use this in order to help the doctors? I thought this was kind of helpful to see, because I mean, doctors need help, and everybody would appreciate this. In order to get to activity-based management and accounting, we need to figure out how to make the doctor document precise enough, and they need help more than just consulting services in order to do this. They need consistent support through the technology. So what we brought to the help of the doctor is what we call computer-assisted physician documentation, which is essentially, as they are documenting, the computer is looking out for them to say, here's a potential gap in the documentation, here is potentially not specific enough yet in order to justify the full encoding charge that is required here. I believe something like this is much better to see in practice, because there's a little magic going on. So what I brought here is a recording of a doctor documenting, and unfortunately only people from the upper half of the audience will be able to see this. So you will see somebody creating documentation thanks to AI, to artificial intelligence. They are documenting and dictating, the computer is listening and then provide feedback, and it will say, hey doctor, well done, except that there's insufficient specificity for certain things, and by the way, it seems to be a likely case of sepsis that we're dealing with. Do you want to add this to the documentation? So please allow me to just play through this in order to give you a sense, because this is real world. So this is a system that automatically encodes in ICD, basically in SNOMED, and derives from there the ICD-10 codes to understand where the gaps are and help the doctor to do a better job. So
insert SOAP template. The patient is a 66-year-old male who came in today for follow-up after a visit to the ED 6 days ago, period. He was there because of a fall and confusion and is known to have congestive heart failure and hypertension, period. CT scan was negative for stroke, but he was found to have a UTI, period. He started macrobid that day and blood work was done yesterday, period. Today he feels ill, open quote, as if I have the flu, period, end quote. He is febrile, complains of right flank pain, and is hypotensive, period. Next field. He still has an altered mental status, and I'm unable to conduct a full exam, period. He has tachycardia and a fever of 102 degrees Fahrenheit, period. No known drug allergies. New paragraph. Poll CBC results. Show CAPD.
So here there you can see
Next
that complaints about unspecified clinical condition of sepsis.
Considering patient disposition and recent hospital contact, I want him to go back for observation, period. Insert before congestive. Chronic systolic. Next field. Order an immediate CBC, comma, start IV fluid, comma, rule out septic shock, period. CC Dr. Jones of the critical care team, period.
So that's a good point, because we're done. I just wanted to show you a little bit of magic of a computer being able to understand what the doctor intends to do, trying to correct the doctor through nudges. So instead of alerting them, we're trying to tell them there is a gap in potential documentation, and you can see the outcomes for this allow us to move the curve to make sure that the CPI people have less work to do, that we can improve the case mix index simply by providing feedback at the point of care already. So I appreciate the opportunity to show you a little bit of this. Thank you so much.